Live now. Hi everyone. A very good evening everybody here who is joining us for a webinar. My name is Bhavna Duggal and I am here representing the SI UK team. First and foremost, thank you everybody who has joined us for a webinar today and welcoming all the students and parents if they are present. So actually who have taken out time and investing your time during this pandemic and joining us here today. On this note, few of may not know that what SIUK is and perhaps what we do. So just quick introduction on SIUK. So SIUK is a global organization with its presence across more than 40 countries. In We are the official representatives of UK universities as well, and we assist students across the globe to seek admissions in the top universities with our premium servicing for Oxbridge, Russell Group, and other non-Russell Group universities. In case you need extra information on our services, requesting everyone to visit our website, that's www.studyin-uk.in. And so let's begin. And on this note, I would like to introduce our key speaker of the webinar today. That's Dr. Steve Neal. Thank you so much for being here today. And, we are not enough to thank you for having you here and helping students and professors to understand artificial intelligence and robotics, and the future's prospects. So I would like to request you to overtake and educate our audience on AI and robotics. So over to you now.
Great, thank you very much. So we're going to start off with a short presentation about the new MSc that we've brought in the school. It's between the School of Engineering and the School of Computer Science, and it's on robotics and artificial intelligence. And to discuss this, I've got one of the academics from the School of Engineering, Bernd Poor, and so he's going to give you an introduction to our Robotics and AI degree program. So Bernd, over to you.
Thanks, Stephen. So I work in robotics and AI, and so I've been asked to talk a bit about this here. So I've got a couple of slides for the degree program. So hopefully everybody can see that. And so we have a brand new MSc in robotics and AI. So as you see, it's a joint degree between engineering and computing science. And so I've been asked to have a chat or present you this degree program here. So it's taught jointly by the School of Engineering and Computing Science. So therefore, as you know, computing science, they are the center of the AI development, and obviously working in this field very hard and very intensively. And on the school side, obviously we have the applied side, like robotics especially. So that's the reason why the robotics aspect is here pretty important. So the so the whole program has 60 credits of core compulsory courses and 60 credits of optional courses. So in the 60 credits, it's roughly so 20 credits is one module usually, and then so you see that these are 3 modules roughly compulsory, and then you have another 3 which are optional. And so in the options you can specialize in the area you would like to focus on. So rather on so either high level engineering or more computing, or maybe you would like to have a mix of both. So the selling point from our point of view is that we focus really on the robotics point of view to have a technical focus there. At the end, we would like to solve problems with AI. So I for myself have been working on robotics and using robots all my life to develop new AI algorithms and also benchmark AI algorithms, because at the end you need to do it with a proper hardware platforms here. So you see core courses here are robotics M. So this means you're really working hard on the robotics part. You have classical control here, and you have a robotics team design project. And then on the other side here, so you can choose between either algorithms, yeah, so machine learning and AI, and computer vision methods. As you probably all know, deep learning is highly rooted in computer vision, and so therefore that's a very important aspect of this. And but we have also a very powerful team in computational social intelligence, where there's interaction with robots and humans, which is obviously important. And we have also the human computer interaction team in computing science. And then on the other side, in engineering, we have at control, we have signal processing. That's what I'm teaching as well. And we have, for example, also here like real-time embedded programming. Yeah, so where you're just writing really producing actually a product which you have to present. And this year we had, for example, a satellite tracking system as a real-time system, and that's obviously a robotic task. And you can think of AI working in this field to improve the tracking algorithm. And then obviously on the other hand, we've got power electronics. Yeah, so power drives, and as you know, like self-driving cars, heavily driven by power electronics. And so what is really important is in this degree program is a team design project where you're working in a small team of a few students to combine all these different approaches, and like robotics control. Then you've got the machine learning part, and of course with that you learn transferable skills like teamwork, project management, and also software engineering, where I'm quite keen on that you're at the end you're producing something of high quality, which is really important in this area. Yeah, so then in the summer, of course, you're doing your individual project, which is over the summer. And so in this, so you see here as these images here. So there's Ewan McGuckin's electronic fish, yeah. So which is he has been working a lot. Then obviously we've got also industrial robots. Computing science has using this all the time. We have a very powerful group of working with drones. We have got a group working on flexible electronics, and of course also you can also build your own driving robots, and doing projects like self-driving cars or improving algorithms in this area. So I'm working in this field of improving algorithms for self-driving cars, and that's obviously part of that. We at Glasgow University, beyond the just the taught modules, we have societies. So you see there's quite a lot of engineering activities in the societies here. So we have a general engineering society. We have the female engineering society. Quite famously, we have the Glasgow University racing team. So they are building a racing car, or have been improving this for many years. And sometimes you see the racing car racing around the university on campus. Especially in these times when there are not many students out there. We've got the wind turbine design. We have a very strong biomedical angle also there. What I haven't talked about with rehabilitation engineering and prosthetics, and obviously the Robotics Society. We also work with sustainable technologies, which also feeds into this, and AI is used to optimize the power grid, for example. Audio engineering, and we've got also aerospace engineering, which obviously also uses AI. Yeah, so that's all. I don't want to talk forever over these slides. I think it's more interesting to answer some questions, how this all evolves, and so how you can be involved in this program and what you can learn from this program. So I hand now back and answer questions. So where are the questions? Let's have a... Don't be shy asking questions.
Hi, Brent. I think the student will ask question at the end of the session. I think even Stephen have something to talk to the students, right?
Okay. Okay, so let's just hand over to Stephen.
Yeah.
Okay, thanks, Bernd. Okay,
Yeah.
so my presentation's more information about what you would get on a PGT degree program at the University of Glasgow. So if I share my screen. Can you guys see that okay?
I can see it.
Great. Okay, so my name's Stephen Neal. I'm the convener for postgraduate talk programs. So that's our MSc degrees in the James Watt School of Engineering. So James Watt School of Engineering is part of the University of Glasgow. We are highly ranked university, 65th in the world. We're old, established 1450s. We're large, 26,000 students. That's gone up a bit since then too. And we're also quite broad. So some of the breadth you can see from what we do in engineering. So within the School of Engineering, we have academics across 5 different research divisions covering aerospace sciences, biomedical engineering, electronics and nanoscale engineering, infrastructure and environment, and systems, power and energy. So the new MSc degree, Robotics and AI, fits well into our electronics and nanoscale engineering, but as Bern has just described, AI can be found in other parts of engineering as well. So it's not just robotics and control, but teaching-wise, our research maps onto 5 teaching disciplines. So the aerospace engineering teaching discipline, biomedical engineering, civil engineering, electronics and electrical engineering, and mechanical engineering. And within each of the teaching disciplines, there are 1 or more MSc degree programs. So in aerospace, we offer 1 MSc, or you can do the same MSc, but taught joint with the management school. So you do half management courses and half aero. Biomedical engineering just has 1 MSc at the moment. Civil engineering, we have civil engineering or civil engineering with management, and then structural engineering. Well, most of our MSc degree programs are actually related to electronics and electrical engineering. So we have a computer systems engineering, straightforward triple E with management. There's 1 nanoscience and nanotechnology. We have our sustainable energy, which is part of this discipline. Electronics and photonics manufacturing, and then the new one, robotics and AI, falls under this discipline. It's a very exciting area for PGT students. So actually, more than half of the school's PGT students come to study some form of electronics and electrical engineering, and it's rapidly growing as well. So we're seeing a lot more students coming, applying to us and studying with us. And the other part of the college, which is also rapidly growing, is computing science. So already engineering and computing science are the 2 largest parts of the college for PGT students. And they're also the fastest growing too. There's a lot of good collaboration between engineering and computing science, and also healthy competition as well. And yeah, this degree program is a good demonstration of the collaborations that go on. And then finally, mechanical engineering, where we have mechanical engineering, we have mechanical engineering with management, mechatronics. So obviously has some relation to the robotics control. So we can say mechatronics is the science behind this, but with the new degree we've brought in with robotics and AI, you would get a much more computer science flavour of it, with half that being taught in the computer science school. And finally, product design engineering. When you come to Glasgow, we have an advising system. So each student is assigned an advisor of studies. So this is someone you can talk to. They can talk through your choice of courses, any health, any personal problems, issues. You always have somebody there who can talk to you. The advisors then have a senior advisor, Hugh McGukin, and a chief advisor. So there's a support structure in place, which is fair for all of our students and our international students to use. So we have two start dates for most of our PGT programs. So the usual one is to start in September. So you do one set of talk courses from September through to December, and then exams in December, and then another set of talk courses from January to the April-May exams, and then do the MSc project over the summer. But there is another entry as well. So we have a January entry, and that's what's on the slide here. So for a January entry, you do one set of talk courses from January through to March, and then exams in April-May. Then we do the individual project over the summer, and Bernd described a little bit about some of the projects that could be available on this robotics and AI degree program. The individual project really is the highlight of any PGT degree. It's where you get to really put into practice what you've learned and study in depth into an aspect that you're really interested. The way we pick the individual projects, the academics will propose projects which are related to their research. So Bernd mentioned a couple of the research groups and what's going on. So they will suggest projects that they think will be a good project to work on over the summer. But students are also invited as well to talk to an academic and propose a project so they can have input into what they're going to be studying on through the summer. At the end of the summer, we have a poster conference. Each student produces a poster, and we get everybody together. So 350 or so MSc students produce quite a large poster conference. It's really a great exhibit of all the research that's going on in the schools, because the projects relate to the research groups. It's really the one time that the school can get together and everybody can see the research that's going on. It's a real highlight of the year, and we invite our industrial advisory board to this event as well. So we have large local and international companies that work with us that send representatives along to our industrial advisory board. And recently, actually, we've got them to do some marking of the posters. So we get them to have a look at all the MSc projects that have been going on. They can talk to the students. They can look for people they want to hire. They can then do some marking for us and pick out the posters that they think are worthy of prizes. And then if January starts, you have the next set of taught courses, which are then done from September to December. So it's still a 1 year long MSc. It's just in a slightly different order to the main September start. So September start, you do all the teaching and then the project. And if you do a January start, you do one lot of teaching, the project, and then the other set of courses. So how do we teach? Traditional lectures, tutorials, practicals, labs, computational labs, project work, self-study, exams. There's also increasing use of non-traditional lectures where material is put online, and most of the contact hours then comes in lab style settings where you get to have a lot of contact with the tutors, the lecturers on the courses. So we have images of these, so from traditional lecturing to small group teaching and final examinations. An example timetable that you would get in a typical engineering MSc would include quite a lot of scheduled face-to-face time with the academics. It's more than in most parts of the university where students may only have a couple of contact hours a week. We have lectures, labs, tutorials, and so you get a lot of contact time with the academics. So this is an example from mechanical engineering, but all the engineering PGT programs are similar in the contact hours. We use a software package Moodle where all of the information that you're given through lectures is uploaded onto Moodle. So you can follow all of the material that you get on these web-based pages. So lectures are uploaded here, tutorial sheets, experimental sheets, work is handed in over Moodle. So it's all administered by this one site. Methods of assessment. So each course will have reports that you need to write, assignments, labs maybe, or presentations, some kind of continuous assessment. Very few are just exams, but most do have an exam at the end. And then when we get the exam marks back, we put them through into a progress board, and then you progress through your MSc and hopefully then graduate after 1 year with your MSc. So I talked a bit about the project already. So it's worth highlighting because it is the part of the project that the students usually get most benefit from. We publish this list of projects. They will reflect your degree program. Conducted over the summer, so you're not doing courses at the same time as your project, so you can just concentrate on the project and get a real in-depth study into the project. We assess your work during the project, you write a report, and then the poster conference I mentioned as well. So here's some images from previous poster conferences. It's hard to take good images of the whole thing with hundreds of students in it. But yeah, this is where you can show your work off to your fellow students, to all the academics from the school will be visiting to see the students that they've supervised and other students within their disciplines, and the industrialists as well, who will be going around and marking projects. And yeah, a typical poster that's presented at this event. So Bernd mentioned the structure with the Robotics and AI degree is made up of core courses and optional courses. So this makes up to 120 credits of taught courses. And the GPA that you get across your core courses and then combined with the mark you get for your project determine the degree classification you get. So you can be awarded the MSc, or you can be awarded the MSc with merit, or you can be awarded the MSc with distinction. We have a student staff liaison committee. So this is a committee that's made up by one representative of each of the degree programs. So I went through the list earlier. So we now have 18 different MSc degree programs. So we have a rep from each and a couple of academics who meet with this liaison committee where students can talk through anything they'd like to discuss about their degree programs. So for Robotics and AI, we'll elect a rep at the start of the year, and that rep will come along to this liaison committee. They can present things that their students on their course have asked them to discuss with us, and we can go through them. And just at the start of the summer, we send out the postgraduate taught experience survey. So this is worth looking into. This will tell you about the experience of previous students. Most universities in the UK will give this survey to their students, and you can see feedback from the students who've taken the degrees at that school and see what they thought of the degrees. So we get very good feedback from our PTES for postgraduate taught experience survey. So please do go and have a look at it and see what our students think of the degrees. And at the end of the year, everybody, well, we graduate you. So this is one of the big buildings in the University of the Butte Hall, where we're having a large graduation ceremony, and everybody gets their degrees. Okay, so that's a run through of a bit about what it's like to do a PGT course at the University of Glasgow. And so, yeah, we'd be happy to take any questions specifically on robotics and AI, and hopefully Bernd can answer these, or studying at Glasgow in the James Watt School of Engineering, and I'll try and answer these. So yeah, please do let us have any questions you have.
By the way, while we are waiting for questions, I just mentioning we are also on social media, so it's not just the classical websites, but University of Engineering has Twitter feed. I'm not sure if you see this on our chat here, but I can still quickly share the screen. That oops, I can't. Somebody blocked my.
It's probably
Stephen
just a bit of shared.
Yeah,
okay.
Can Stephen, can you unshare? Then I can share. And so that basically where is it here? Yeah, so we have also our Twitter feed here, which is a mix of funny stuff and also more serious messages and also what's going on at the school just now. So you find a nice just the interesting mix of events and also what is happening. So it's not just official bulletins, but also what's happening on the student level and all different kinds of levels. So therefore, I recommend that you subscribe there and have a look. And you also find me sometimes tweeting there. So I tweeted also. We had I was supervising a project, a module called Real-Time Embedded Coding, and we had 20 different products produced, and so I also tweeted them all out, and so therefore all these things are also on our social media feed, and you can also obviously also reach us through that. And so let's see if we have any questions coming in.
Yeah, we have questions from the students. So the first question is, sir, I'm planning to take up artificial intelligence after 2 years. So what kind of job experience should be helpful to get admission and job in UK or else in Glasgow?
I don't think in terms of the admission, I think Stephen probably knows more than me about this, but in general, job experience has nothing to do with the admission process, isn't it, Stephen?
Okay, so most of the admission is based on your grades, so good grades get you in. But if they are borderline, then our admissions people, they send the application to me. And actually, work experience is something that I will look at. If you've been working in a technical area that relates to this degree that you want to study on, then that is something that I can consider. I'd also consider you write a personal statement with your application. And so this is something that I read quite closely as well. Look at why you want to do it. Try and work out if our degree is the right one for you. So in the borderline cases, they do send to me, and I will look at things like work experience. I think the question was along the lines of what kind of work experience would be helpful for this. So anything that's technical would help. It doesn't have to be spot on you're developing AI code to be helping with this. But if you're working at a technical company that's helping you start off your career doing apprenticeships in something that's engineering related, then that will certainly look good on your CV.
Mhm. I mean, in terms of skills, obviously, coding is always extremely useful to have good skills there. Yeah. So obviously, and it's a postgraduate degree, so we don't teach you coding from ground up. So there should be a baseline level of coding. The coding languages are, as you know, AI. The usual coding language is Python for anything what's not real time or post processing. Anything what's happening in real time, like especially in robotics, will be C or C++. So and so therefore, a baseline knowledge of C and C++ is useful. I've seen it in my class, real time embedded, that most students just now have mainly knowledge in C, but they learn very quickly the C++ element of it, and then also just wrote beautiful code. As I said, it's all tweeted out. You can have a look on their GitHub, and I can also retweet that here via the account again. And so therefore that's I would say is the main issue. Yeah. So anything else I would say in terms of electronics, also robotics or something like that, it's it's doable within this year, I would say. Yeah. So especially if you remember, it's a team project which is starting this, and in the team, if you're choosing your mates carefully in this and creating a nice mixed team where somebody is able to do the hardware and somebody else is doing software, then you can learn from each other. And then also those who have a pure software background usually learn very, very quickly the hardware aspect, and also the other way around, of course. But I would say software aspect is obviously important.
Okay. So the next question is, what is GPA requirement?
Stephen, can you say that?
Yes, so we have a baseline of entry of equivalent to the UK 2-1. What that equivalence is, it does vary not just country to country, but university to university. Um, Sanju, do you have specifics?
Yes, thank you, Steve. So basically, from an Indian institute, we normally look at a 65% overall in the graduation. And in case if it's a CGPA, it's a minimum 2.6 CGPA out of 4 would be the minimum requirement in order for you to be eligible for the academic entry requirement. Keeping sure that you do not have more than 4 backlogs. Now, these 4 backlogs that we talk about should also not be from the core subjects. If you are having backlogs from the core subjects, then the admissions team might take it as a rejection. And as Steve said, at the borderlines, these applications might take a longer time period in order to get an offer, which goes to the department for more screening to find out if you could be eligible by looking into extra other work experience, whether you're contained or not. So in general, if I have to put it, the academic requirement would be a 65%. Just adding on to that, an English requirement for the 2020 intake alone, because of the pandemic situation, we are accepting CBSE and ISC 12 standard English marks, 80% above. But if you're looking for future intakes for September 2021 onwards, in that case, we will need an IELTS test of a minimum of 6.5 in overall band, and individual bands not less than 6 in the individual bands. That will be the IELTS requirement.
Yeah, thank you, Sanjeev. So I have further extension of the course, how to get into these programs, AI and robotics.
So is the question, just to rephrase the question, is the question asking us whether what is the graduation required in their level to be accepted
Yeah,
in
what is
this
the
course?
entry criteria? What is the entry criteria and the process to apply for these courses?
Okay, in order for the process, it's an online process, and SIUK will be able to help you with the application process. As long as you have an engineering background, especially with electrical electronics engineering, mechatronics, and also mechanical engineering, you will be eligible to apply for these courses. And just correct me, Steve and Bern, with students from computer science background also be eligible to apply for this course?
Yes, that's right. So a lot of our PGT programs, they are set up so that they can take students from not just one background, so it's electrical engineering students to studying electrical engineering. And for this one, Ben's already mentioned programming is important. So we would look for programming on a transcript. So you were right to say mechanical engineering students could apply, but we'd have to see some programming on the transcript. That would have to be there. So object-oriented programming, some form. But yeah, computer science across the engineering backgrounds, if they have maths, some programming, then yeah, they'll be eligible to apply. Yep.
Okay. So the next question is, tell us about some projects.
Great. Bernd, do you want to mention some of your projects that you could offer for this MSc?
Yeah, I mean in general, so we have a couple of different robotics applications. What I've shown on the slide. So we have drones in the department, loads of drones, and controlling them and using AI to control these drones. And as you know, AI is heavily focused on image processing, and so therefore projects would just focus on image processing tasks like drones navigating and detecting certain images or landscape and using this to navigate. Then my own research is in the area of actually developing new algorithms, AI algorithms, which are spin-offs from deep learning or algorithms which are further evolving from this area. And so my interest is in driving. And so therefore, if you want to follow a lane and you would like to improve this driving scenario, so we have developed robots which are first driving quite shaky through the road and then just becoming better and better while they're doing it. And so I'm working on the algorithmic side, and then obviously putting this on a robot and actually seeing if the robot is able to improve its driving behavior there. And so then in computing science, they're working pretty much with robots doing grasping and doing dexterity. So we have there's a Baxter robot and other robots with robotic arms, and they're able to reach and train robots to do these tasks. Again, they have very good knowledge in image processing, and that's also getting inspired by biology. This is also what I do. Um, and then obviously we have got biomedical engineering, which is doing rehabilitation engineering. Yeah, so where we build robots to help people to walk, and so I've done that by myself. And so I've developed the fastest robot in the world a couple of years ago, called the Runbot, and used AI to improve the walking behavior of the robot. And I'm still working on this. And we use that to for example improve the walking of people with spinal injury or with walking disabilities. And so therefore there's quite there's a very wide range of projects. And then we've got the power engineering, which I shouldn't omit here. Yeah, so the power engineering people, obviously they have turbines, they have got wind turbines with unreliable power sources, and you need to have AI to predict when there's wind, when there's no wind, when the power grid needs the energy. And so you need to have algorithms which are able to predict that. Yeah. So and so all these projects have been running already at the school within different domains, but now it's pooled together in this MSc program, where you've got central robotics, and then you can apply this in different areas. And yeah, with that you can choose one of these projects, or you can also create your own. Yeah. So which is also encouraged. Okay, back to you.
Yeah, we have a student, Sai Karthik, and he's asking what is the future of this AI and robotics in transportation? And there's the next question, which is the further extension of this question. Kindly share future scope of artificial intelligence?
Future scope, yeah. If I knew the future scope of AI, I would be very rich, I think. Yeah. So therefore, that's a very difficult question. AI will obviously stay with us. The algorithms in especially in image processing, as you know, are very well established nowadays, and used in image recognition, like face recognition, but also in controlling um, you know, um, all robotic industrial plants and all different kinds of applications. Yeah. So what was the other question?
What is the future of this? I mean, the robotics and artificial intelligence in transportation.
In transportation, okay. Yeah. I mean,
Yeah.
transportation is obviously just now in the on the specific point of self-driving cars. We now obviously research is going on there, and will be going on for obviously many years, and improving cars. It's not just now. When you think of the Tesla car, so they are pretty good at lane following, but there's way away from fully autonomous cars, and so research will be going on for years. And in general, in transportation, obviously, AI, I see personally also in the scheduling and deciding which way of transportation you're going to use. Yeah, so are you going to use a car, switching off at some point to public transport, going back into another car, and so AI will be deciding, or in the future also, which means of transport you're going to use. And so therefore it's not just the driving itself, but also the infrastructure decisions, and the decisions what you do. And this just ties into the research in computing science here, where these areas are covered. And so therefore it's very wide. And it ties in more into data science in this respect. Yeah. So therefore you're getting information about different traffic flows, and then using this information to feed this back to a person in an app, for example.
Yeah, I think this is a really good question because I mean, we know there's a massive shift happening with transportation, and it's being pushed by the regulators. The government have said in many countries that they're completely phasing out petrol, diesel cars for electric. When you have electric cars, then the economics change very much. I've seen people suggest that the electric cars with the extra mileage they can do, it becomes more economically sensible that you share these, and you have more like an Uber style system where the cars just come and they pick you up, and nobody really owns a car. It could be we've bought our last personal cars, and we know that this massive shift is going to take place into electric, and it could be that with AI, every car and every journey, every passenger trip will be powered by AI, and it'll be pervasive. It's yeah, a really exciting time to be considering these transportation networks within our life. It's going to completely change.
Okay. So the next question is from Rinisha, and she is asking, I'm from an electronic background, and will I be eligible for to take up this course?
Okay, yeah. So an electronic background would be a good background for this if you've done some programming as well. So as Ben was saying, it would be very difficult to give you the programming that you need within a one-year degree program. And so we are looking for some prior programming. So if you have that, which you quite possibly do on an electronic undergraduate degree, then yeah, you'll be suitable for this.
Yeah, I just chip in there that what I said before. So there's no need to be a total whiz in object-oriented programming. So therefore, if you as a student have done pure C programming on a microcontroller or Arduino or something like that, and you know the basic coding concepts, and you're familiar with that, so it's a bit like learning when you're learning a language. Yeah. So if you are good enough to be on a basic level, and then you need to up your game, that's just perfectly fine. So I had always students just with C knowledge, then the object-oriented part, and going from there to C++, or in Python to go to object-oriented coding there is usually very, very easy to learn, and it's doable. And I see this that students pick it up very, very quickly.
Okay. So the next question is from Rishi Kumar, and he's asking how many study hours will we have in a week?
Stephen?
Yeah, so I put up an example timetable here. So we won't have the timetables for next year sorted out quite yet, but I can pop it up. So this is like a typical timetable. So you can see you'll be taking 60 credits of taught courses at the same time, which could be 3 20-credit classes, 6 10-credit classes, or a combination of 10 and 20-credit classes is more normal. A 10-credit class would have 2 lectures a week, and a 20-credit class would have 4 lectures a week, plus labs as well. So here we can see on a Monday, 1, 2, 3, 4 hours of contact time. On a Tuesday, 3. On a Wednesday, 4 hours of contact time again. So, and the least is Friday with 2. So 2, 3, or 4 hours of contact time per day, built up of lecturing blocks and lab blocks. That's that will be the same across for this robotics and AI one, MSc.
Yeah, I should just also chip in there that when you think the timetable looks just semi sparse, but obviously you need to also work on your own time on this. So labs are very often open-ended in the way that there's a certain contact time where you're meeting with the supervisors, but the labs are usually open for MSc students 24/7, and so therefore you can very often do this in your own time, and then with that just scheduling their own meetings with your teammates, and so therefore it's not this rigid that you think, okay, so there are these slots and then that's all finished. Yeah, so it's an MSc program. And that's the fun of it, that you're getting usually quite open-ended tasks, even in the classes, and you have to solve them, and then you just do this in collaboration with the with lab technicians, with the workshops, and so these tasks are usually very open-ended. Yeah, so it's not a classical undergraduate teaching, so therefore it's much more flexible.
So the next question is from Shweta, and she's asking, I'm completing my degree in non-engineering courses. If I want to join this course of artificial intelligence and robotics, can I join? If yes, without any knowledge of engineering and skill.
Yeah, as we said before, a requirement from the practical point of view is definitely coding. So without any knowledge, learning coding is very, very hard and virtually impossible, I would say. And so therefore, a certain degree of coding and also mathematical skills are required. Stephen?
Yes, that's right. For a non-engineering degree, we would look for engineering standard maths, and then specific things for each degree program. So for robotics and AI, that would be programming. But a student with a physics background, they could show that they had engineering standard maths, or other sciences would have that as well, or maths background. So yeah, for maths is one requirement, and then the specific requirement would be programming for this one.
Yeah, and With coding, like many people do, you might have learned coding on the side, as a side project, or doing some exciting side project on GitHub or something like that. So if this person is confident, if you're confident with coding, and you can demonstrate that, then of course you can do it. So but especially computing science is still quite a young degree, so therefore you might have just learned it somewhere else. And so, but mathematics again is also something what Stephen said is required. Yeah, so obviously robotics, there's quite a lot of nasty trigonometric transformation in there. Yeah, so and you need to get a robotic arm from there to there, which combines quite a lot of sines, cosines, and other things. And so therefore also that you need to be confident that you're able to cover that.
Yeah, I mean, you were very right, Bernd, to point out if you've coding experience outside of your studies, put it in your individual statement. They do send borderline cases to me to review, and when I review them, I do look to see, do I think that this person could cope on our degree program, and that's what we base our entry requirements on. So yeah, detail what you've done, and apply, and we'll have a look at it.
Okay. So we have Vijay, and he's asking, so currently I'm doing BTech IT. Uh, I will get my degree in 2021. So will it be better if I start AI progression after that?
So I understand from the question that they're going to finish their degree in 2021. And
Yes.
then the question is, should they then do a master's in AI after that?
Yes.
That sounds like a good idea to me.
Okay. So the next question is from Dinesh Kumar. He's asking, sir, next generation, we use AGI or ASI?
So he means basically, next generation, if you're using generalized AI or specialized AI,
Yes.
as far as I understand the question. Yeah. So I mean that's obviously a question which is going on just now in the everywhere. Yeah. So and obviously generalized AI, everybody wants that. Yeah. But that's just something obviously which is many decades probably away, I would say. But obviously we're working towards that. But there is very exciting research going on towards generalized AI, and obviously we at Glasgow we're also working on this, and and therefore projects or the research projects, the team project, and also the MSc projects, they can obviously join in this research and contributing to this to generalized AI. And I have quite strong opinions regarding this. I'm not voicing them here because otherwise we might just end up in a discussion here, which is going on till midnight. And so therefore, but they are very exciting ideas in this area, and I'm pursuing certain ideas in this area. Other people pursuing other directions. It's a very dynamic field just now, and everybody is aware this needs to be solved. And obviously Glasgow, both in engineering, electrical engineering or engineering in general, and computing science, are working on this. And so therefore anybody who is joining the program will be obviously can contribute to this and do the MSc project in this area, yeah, and contribute and plays a small part in improving it. Just now, AI is mainly based on deep learning, as probably most of you now who are listening in. So deep learning has become very successful in the last 10 years. The algorithm and all the success, also the Atari video games, and so they're all based on deep learning, and but the other algorithms, they have not evolved very much, like Q learning, for example. And so therefore there's a lot of research going on to improve the other parts of that, especially in robotics. As you know, robotics is decision making, and robots making hard decisions. That's a pretty bad choice just now, and so where soft decisions or very narrow decisions are very easy to do, like recognize his face, for example. Yeah, but anything beyond this is basically just in the realm of reinforcement learning, and there's just a lot of research is happening there, and it's happening at Glasgow University, of course. Okay, back to you.
Yeah, we have Rishi Kumar, and he's asking, tell us about some projects on AI and robotics currently running under the university guidance.
Currently, well, I don't have a massive overview of everything, yeah, but also obviously other guys can chip in. So my projects are in the area of robotics. Yeah, so I'm just now working on learning algorithms, which you know are modified algorithms of deep learning. They're no longer deep learning, but something new. And these are online algorithms which are basically improving the behavior of a robot while the robot is doing it, so learning it. So it's not just just having 10,000 training examples, train the robot for 3 weeks, and then I see if it works. But in this case, the robot basically learns it while it's doing it. And that's just my interest to have very fast learning algorithms where actually a robot can learn it while it's doing it. I know it from in computing science. They're doing a lot of image processing. They're just improving the image recognition algorithms and taking a lot of inspiration from the human brain or from other brains by using receptive fields and using these algorithms to detect objects and to guide robots to certain objects and to grasp them. Um, we have just now AI projects in the area of energy, so to predict when turbines need to have more when there's a power demand happening in the future, that the AI is able to detect that. And as I said, also in the area of prosthetics, is AI used, and to improve the walking behavior or the walking of people. And yeah, so AI is used in many projects. Also even my student projects, what I have just now in real-time embedded coding, we had also AI there. They trained an AI algorithm to turn sign language instantly into text. Yeah, where somebody just was sitting and I can't do this sign language obviously, but it's turning this into text, and that just worked very well. And that was just basically like a project of 3 students in the real-time embedded coding who basically used that. But we had last year also a student project in real time where an AI algorithm was detected bad gait, or so if somebody is walking not properly, they're just dragging his feet or something like this. So they used sensors on the legs to detect the proper walking and gave feedback via an app if the person is walking properly or not. And so you see the applications are very wide, and we have in general very good general knowledge which algorithms are there, and then you as a student, you can decide where you want to use it. Okay, back to you.
Yeah, so we have Sanjay is asking, can you please discuss about the scope of robotics?
Scope, that's a very general question there. Yeah, so as robotics means really in our case in the industrial environment. Yeah, so the scope in this way really means applied in the program. Yeah, so I also use robotics in other areas, or other people using it, robotics, to understand, for example, animal behavior. But in this case, it's really an industrial application, and so in this area, so that you have industrial robots doing certain tasks, and you're using AI to improve that, or to teach the robot to do certain things. So let's see, and then obviously robotics also in terms of autonomous behavior, like autonomous cars. Obviously, that's a misnomer, because also a car you would like to have going from A to B not the car deciding I want to go to the beach now and developing some life of its own. So therefore, this way it's also the robotics where you have a certain goal and you're telling a system what to do, basically.
Yeah, so we'll move on to the last two questions. We have Muskan. She's asking about what is the criteria for scholarship.
Stephen, can you say something about that?
Yeah, so there are several scholarships available. If you look at the webpage for the Robotics and AI MSc, then one of the tabs is on, I think it says fees and scholarships. So you click on that tab and it will show you the fees of the course and all the different scholarships that are available. Some of the scholarships are only available to students from certain regions. So have a look through and see which ones that can apply for you. A lot of those scholarships are assessed automatically. So when you put your application in, you will be assessed, for example, for the Dean's List, and they will give these scholarships to the best students who've applied. Others, for example, the Commonwealth scholarships, you have to apply for individually. So there's a dozen or so different scholarships. Have a look through, see which ones you're eligible for. They'll tell you on each of them whether you need to apply for it individually or if you're automatically assessed. So have a look through. Sorry, Sanji, do you want to?
Yeah, just to add on to that, in general, we definitely look at your academic performance as well, making sure that you have a minimum of 80% and above in percentage, and from a CGPA, it would be a 3.5 and above in order to be eligible for any of our top scholarships. The range of scholarships is normally a £10,000 scholarship, and there are some scholarships that we also give on the full tuition fees as well. But bear in mind, most of our scholarships are very competitive, and most of the applications that we receive are above 80-85% of marks that they get. So early applications is much appreciated because most of these scholarships tend to fill up quite early in the stage. So early applications is what is advisable to make to the University of Glasgow.
Okay, so moving on to the last question of today's session. Please tell us about the part-time opportunities to the students within the campus.
So I think the question was for part-time study, is that right?
No, part-time earning, part-time jobs within the
Right.
campus.
Okay, I don't actually know the answer to that. So I don't think there's much part-time work on campus. However, the University of Glasgow is in one of the largest cities in the UK, Glasgow, and so there are a lot of opportunities for part-time employment close to the campus. Probably not on campus, but close to the campus, yeah.
Okay, so this brings to an end of a question and answer session. So I'd like to thank Stephen, Brent, and Sanju for this informative session and
Pleasure.
spending your time with the Indian students and explaining them about the artificial intelligence and robotics prospects, scholarship aspects, and other things. So thank you very much for your time. And again, I'd like to thank the students those who have participated. Thank you and all the best.
Okay,
Thank
pleasure.
Very welcome. Okay, good, thanks.
you. Have
Bye,
a good
everybody.
evening, all of you.
Thanks.
Bye-bye.
Okay, bye.
Uh,